Hello, yes, and welcome to our 5.5 notes, which are all about solving nonlinear systems. So everything we've done so far has been linear systems of equations. What if our systems of equations aren't linear? And to get started with that, I would like to fill out these true and false questions, or statements really. So I'd like you to go ahead and pause the video, take 30 seconds or so, identify whether each of these statements here are true or false, and go ahead and circle what you think. Alright, so go ahead and pause the video, give it a shot. Alright, let's see how we did. The degree of a term is determined by the exponent of that term. That is true. Remember, so if we have something that's x to the third, that would be degree 3. If we have 2x squared, that would be degree 2. If we have 5x to the fourth, that would be degree 4. So the exponent determines the degree. In a linear system of equations, all the variables have the same degree. That is also true. All of them have a degree of 1. Think if we have x plus y equals 7, that'd be a linear equation there. Both of these variables have a degree of 1. In a linear system of equation, each system has exactly one solution. That is false. We know that there could be one solution, no solution, or infinite solutions. So today we're going to look at nonlinear systems, and this is really probably my favorite section of this unit. So in a nonlinear system, it's possible for the variables to have degree other than 1. Alright, so using your graphing calculator or Desmos, sketch the graph here. I'm just going to do it by hand. Y equals, I need to subtract x squared, so this would be y equals negative x squared plus 3. This one, if I add x, it'd be y equals x plus 1. So negative x squared plus 3 would be right here. Let's see, there's no stretch or compression, so 3 over from there. 5, 3, 4, 5, and over. 5 and over. And I can connect the dots here of this parabola. Very good. And then the other one, y equals x plus 1, that'd be a y-intercept of 1, and then we go up and over like so. So we're graphing both of these, and remember, solutions of systems occur where the graphs intersect. Oh, I would like to ask you, if we have lines and curves, what do you notice about our intersections? So I'm going to go ahead and ask you to fill in. What do you notice about this graph that we have here? So go ahead and answer that question. What do you notice about the graph? Go ahead and pause the video and then we'll go through it together. Okay, so there's a couple things we could notice. The big idea that I want you to get out of here is that how many solutions does this system have? All right, notice if we look at the solutions here, where the lines cross, they cross in 2 places. Now remember, we had always talked about there's either one solution, no solution, or infinite solutions. But in nonlinear systems, it is possible to have more than one finite solutions. What I mean by that, more than one finite solutions, we can have 2 solutions, we can have 3 solutions, we can have 4 solutions, because now we're dealing with curves and lines and the interaction between them. We can still have infinite solutions, we can still have no solutions, but we can't limit it to just none, 1, or infinite. Now we have to be a little more creative. So let's talk about how to solve nonlinear systems algebraically. So if all the variables have the same degree, we can solve with a matrix. Now if the variables have differing degrees, we need to solve with substitution. There we go. Now remember, our answers need to be written as coordinate pairs, because they are, of course, where these lines cross on the coordinate plane. So for example, our solutions for this one would have been, was that 1, 2, and negative 2, comma, negative 1. Those would have been our two solutions to that system. So let's do some examples together. Looking at letter A here. So the first thing I ask, if I notice this is nonlinear because I have degrees other than 1, right? These are degree 2. Are they all degree 2? And the answer to that is yes, they are. Well, if they are all degree 2, I can solve with a matrix. So I'm going to start by writing this as a 2 by 3 matrix. So I had negative 1, 2, 2, 3, 1, and 15. So in my calculator now, I'm going to second matrix, edit. This is a 2 by 3 with negative 1, 2, 2, and 3, 1, 15. Second quit, second matrix, math, I'm going to RREF, matrix A, and press enter. So when I do that, and I can go ahead and show this work here, I get this new matrix 1, 0, 4 and 0, 1, 3. However, this does not tell us x equals 4 and y equals 3. That is not correct here, okay? We cannot make that assumption. What does this number represent? This represents 1 x squared. This represents 1 y squared. So what this tells us is that x squared equals 4 and y squared equals 3. So now we need to solve this. We take the square root of both sides. Remember, whenever we take the square root, we need to remember plus or minus. So that tells us that x equals plus or minus 2 and y equals plus or minus the square root of 3. So from here, we need to write every combination of x and y as our coordinate pairs. So with that being said, we can have positive 2, positive root 3, positive 2, negative root 3, negative 2, positive root 3, and negative 2, negative root 3. Alright, so how many solutions do we have here? We have 4 solutions, okay? 4 solutions, and we did that again using our matrix. We solved for x squared and y squared, solved for x and y, and then wrote every possible combination of x and y as coordinate pairs. So that's if they all have the same degree. What if they don't? Let's look at letter B. Notice how 3 of these variables have degree 1, but one of them has degree 2. That means we need to solve with substitution. Now to use substitution here, what I would do is I would solve for this y. So I would subtract x squared from both sides, so that'd be negative y equals negative x squared plus 2. So that means y equals positive x squared minus 2. Substitute that into our top equation. So I'm going to have 4x plus 3 times x squared minus 2 equals 9. Distribute the 3, 4x plus 3x squared minus 6 equals 9. I'm going to subtract the 9 and rewrite this in standard form. So I have 3x squared plus 4x minus 15 equals 0. Alright, now this we need to factor. So I'm going to go ahead and just factor with the AC method, A times C would be negative 45. Factors of negative 45 that add up to 4 are 9 and negative 5. So I'd have 3x squared plus 9x minus 5x minus 15 equals 0. Factor by grouping. Take out a 3x. Left with x plus 3. Take out negative 5. Oh goodness. Don't need that parentheses there. Take out negative 5. I'm left with x plus 3. So my factors are 3x minus 5 and x plus 3, which means that x equals 5/3 or x equals negative 3. Fantastic. So x equals 5/3 or x equals negative 3. Plug that in up here now. Figure out what y equals, right? I can use this equation that we have here. y equals x squared minus 2, plug in my values for x's to see what y is. So with that being said, let's start with the 5/3 because it's a fraction. So y equals 5/3 squared minus 2. So that'll be 25 ninths minus, well, we can go ahead and write this as 18 ninths, right? 25 minus 18 is 7. Y equals 7 ninths. So one of my solutions is 5/3, comma, 7 ninths. Another solution, x equals -3, so y equals -3 squared minus 2. Remember, negative times a negative gives us a positive, so that'll be 9 minus 2, which means y equals 7. So that solution would be -3, comma 7. How many solutions did we have here? 2 solutions. And that's because this is similar to the example we had. We had a line and a parabola, right? A line and parabola will often intersect in 2 points. All right, let's try a couple more together, and then we'll have you do some on your own. Looking at letter C. Okay, what do we notice here? All degrees are the same. They're all degree 2 for my variables, which means we can solve this with a matrix. So let's do 1, -10, -102, -1, 2, -2. And let's RREF this guy. So on my calculator, I'm going to edit matrix A. It is a 2×3 matrix. I need 1, -10, -102, huge number, -1, 2, and -2. Enter. Second quit. Second matrix. Go to math up to RREF. Select matrix A. Close the parentheses. 1, 0, 28, 0, 1, 13. So 1, 0, 28, 0, 1, 13. All right. So what does this tell us? This is not x equals 28 and y equals 13. Remember, because we're dealing with x squared and y squared. So this tells us that x squared equals 28 and y squared equals 13. Take the square root of both sides. Don't forget the plus or minus. So x equals plus or minus. Let's see, this will be the square root of 4 times, oh, let me get rid of that. Times the square root of 7, there we go. So x will equal plus or minus 2√7. 13 we're not going to be able to simplify, so it's just plus or minus the square root of 13. Now I need every possible combination. So positive 2√7, positive square root of 13. Positive 2√7, negative square root of 13. Negative 2√7, positive square root of 13. Negative 2√7, negative square root of 13. And there we go. 4 solutions for this one. Fantastic. Excellent. All right. Let's try letter D together. So notice here, x squared, y squared, xy. Different degrees, which means I cannot solve this with the matrix. I have to solve this with substitution. So I'm going to solve, if I add y to both sides, I can see that x equals y plus 1. So I'm going to plug that in for x up here. So when I do that, I get y plus 1 squared plus y squared equals 13. So multiply that out. That'd be, I guess I don't need these parentheses anymore. Y squared plus 2y plus 1 plus y squared equals 13. This will be 2y squared plus 2y plus 1 is 13. I want to subtract that 13 so I can get this quadratic. It will be 2y squared plus 2y minus 12 equals 0. I notice all of this is divisible by 2. So let's go ahead and take care of that. So I'll get y squared plus y minus 6 equals 0. And then I can factor this for y. All right, so I need factors of -6 that add up to positive 1. So that'd be plus 3 and minus 2. So that tells me that y equals -3 and y equals positive 2. Now remember, I have this equation up here that x equals y plus 1. Well, let's use that here. So x will equal when y is negative 3 plus 1, well, that would be negative 2. And x equals when y is 2 plus 1, that would be positive 3. So my solutions are, be sure x is negative 2, y is negative 3, and x is 3, y is 2. Beautiful. Fantastic. All right. Well, hopefully we're feeling pretty confident with these. Why don't you go ahead and try a couple on your own? Why don't you try E and F on your own? Go ahead and pause the video, and then we'll check those together, all right? All right, let's see how we did here with E and F. So first thing I noticed, E and F, squared, 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 they all have the same degree, which means I can use a matrix to solve this. So I'm going to write this out. 1, 2, 15, negative 1, 4, negative 1. Let's RREF this guy. All right, so second matrix. Go over to edit this 2 by 3. We get 1, 2, 15, negative 1, 4, negative 1. Second matrix. Math. RREF. Second matrix A. Close the parentheses. What is this? Gross. So math, frac. See what we got here. Oh no. Well, that's pretty disgusting. Okay, let's double check to make sure I type this in right. Anytime you get an answer that you're like, oh man, that's gross, let's double check the matrix. So second matrix, let's see here. If I just click enter, it'll show. So 1, 2, 15, negative 1, 4, negative 1. All right, well, it looks like that's it then. So that means we have 1, 0, 31 thirds, 0, 1, 7 thirds. All right. So this tells me that x squared equals 31 over 3. Y squared equals 7 over 3. So think about when I take the square root here. So this will be the plus or minus the square root of 31 over the square root of 3. And y will equal plus or minus the square root of 7 over the square root of 3. Now, we don't like that. Let's rationalize these denominators. So square root of 3 over square root of 3 to both sides. Square root of 3 over square root of 3, top and bottom. When I do that, I get the square root that x equals plus or minus the square root of 93 over 3. And y equals plus or minus the square root of 21 over 3. All right, now we've rationalized it, so let's write every possible combination here. I'm going to try to fit them all on one line here. So we will have positive 93 over 3, comma, square root of 21 over 3. We will have positive square root of 93 over 3, comma, negative square root of 21 over 3. We will have negative square root of 93 over 3, comma, positive square root of 21 over 3. And we will have negative root 93 over 3 and negative root 21 over 3. So there are our 4 solutions. Very nice. Notice often when all the degrees are squared, that means we're often going to have 4 solutions. Not always, but that is generally the case because we're dealing with ellipses here, which means they look like this. All right, 1, 2, 3, 4 solutions there. All right, so that was letter E. Let's check how we did with letter F. Now, looking at letter F, we have one that's degree 2, the rest are degree 1. So we're not going to be able to use a matrix on this one. So, let's solve for this x here. If you solve for y, that's fine. I think this x is probably the way to go, though. So with that being said, I'm going to subtract 7y, so negative x will equal negative 7y. Let's see, minus 7, or plus 7, sorry, plus 7, which means that x will equal 7y minus 7. Oh no, this is going to be gross, isn't it? Alright, let's go ahead and set this up here. So we'll have 7y minus 7 squared plus 3y equals 6. Oh boy. So multiply this out. This is going to be 49y squared minus 98, no, 7 times 7, yeah, times 2, minus 98y plus 49 plus 3y equals 6. Okay. At this point, you're probably wondering, Mr. Carter, how are we going to be able to solve this in an appropriate, like, semi-understandable way? And to be honest, we're not. So here's what I would recommend if you get something like this on a test. Now, I don't think you'll ever get something this gross on a test. It's never happened in all my years teaching college algebra. But here's a great moment for you to conceptually understand. Can we get both of these to be y equals? Yes, we can. So let's look at this a little differently. So let's do this in blue. That way we can show the difference here. So looking at x squared plus 3y equals 6, we can subtract x squared, so we'll have 3y equals negative x squared plus 6, and then divide by 3, so y equals negative 1/3 x squared plus 2. Alright, so we have y equals all by itself there. Now let's do it for the other one. Negative x plus 7y equals 7. Add x, so 7y equals x plus 7. Divide, so y will equal 1/7 of x plus 1. Now with this in mind, you have a calculator that can graph y equals, right? So what I would do if I were you is I would go ahead and graph y equals both of these functions and see where they intersect, okay? And actually do that with a graphing calculator. I think if you show this work, you'd most certainly get full credit. That being said, I don't think you'd ever see anything like this on the test. They'd be much nicer. They'd be much more like the substitution problems we did up top with letter B and letter D. That being said, I like to expose you to this type of problem because hopefully we use some problem solving skills here. All right? This algebra is disgusting. And yes, you could quadratic formula that. You're right. I would not ask you to do that though. I'd ask you to be a little more creative. So with that being said, I went ahead and graphed both of these functions here. Okay, now when you do that, you can see your two intersections, negative 1.96 and 0.72, and 1.53, comma 1.22. And those can be your solutions for that one, okay? So I apologize for the curveball, but I want to make sure you're staying on your toes here. So with that being said, why don't you try to stay on your toes and go ahead and try G and H on your own, okay? Last ones on your own, G and H, go ahead and pause the video, try those. I promise, I think they'll be a little nicer for you. All right, G and H on your own. All right, so the first thing hopefully we noticed is that this is degree 2. These are all degree 1s. Get rid of this box here so we can see better. Degree 2, all degree 1. So that means, oh no, we cannot use a matrix. We need to use substitution. I'm going to solve for y by adding x to both sides. Oh, I'm still in my blue pen. That's okay. Let's change it back. Back in black. Y equals x plus 1. And we can substitute that in for this y up in the second equation. When we do that, we get x squared plus x plus 1 equals 3. We can subtract 3 from both sides, so x squared plus x minus 2 equals 0. When I factor that, we get x plus 2, x minus 1 equals 0, which means that x equals negative 2 and x equals 1. See, I told you this one would be easier. I didn't want to shake you guys up too bad. All right, so with that being said, let's plug these values in for y. So y equals, when x is negative 2 plus 1, well, negative 2 plus 1 is negative 1, which would give me the coordinate negative 2, comma, negative 1. When x is 1, we would get just 1 plus 1, which is 2, which would give me the coordinate 1, comma, 2. And those right there would be our two solutions to this problem that we used from substitution. This would be something that's much more likely on the exams than letter F that we just did, okay? So I don't want you freaking out with letter F. I put that in there for challenging you. Obviously, that problem's a little better face-to-face because we can explore that in person. But hopefully some of us figured out how we could approach that problem if we do get stuck on something like this. G is probably much more like what you're going to see on an exam, though. Now, last one, letter H. All right, finally, we're back to all having the same degree. If they all have the same degree, we can, of course, use a matrix. So 1, 3, 10, 1, -4, -4. Let's go ahead and RREF this guy. Beautiful. So second matrix. Ooh, let's close out of everything here. Second matrix. We're going to edit this 2 by 3 matrix so that it is 1, 3, 10, and 1, -4, -4. Second quit, second matrix, math, RREF. Second matrix, A, close that parentheses, 1, 0, 4, 0, 1, 2. Oh, the dream. This is a good one. All right. So this tells us that x squared equals 4, y squared equals 2, which means that x equals plus or minus 2, y equals plus or minus the square root of 2, and now we need every combination. We'll have 4 solutions here. So 2, comma, square root of 2, 2, comma, negative square root of 2, -2, comma, square root of 2, and -2, comma, negative square root of 2. And there are our 4 solutions. All right. I'm hoping we're feeling good about solving nonlinear. Remember, we can use a matrix or substitution. We use a matrix if they're all the same degree, like here with letter E. We use substitution if they are different degrees, like here in letter D. All right. We're feeling good, feeling confident. And hopefully we'll be able to knock it out on our practice problems here. So go ahead, get to work on those practice problems. Mr. Carter signing off. We only got 2 sections left for Unit 5. I'll see you next time.